Yes, sir.
Thank you for reminding. 32. Change in energy is half L I2 square minus half L I1 square. Half L I2 square minus I1 square. Half of L we got from the previous part, zero point 0.2. I2 is 8 square minus 4 square. So zero point 0.1 into 64 minus 16. Zero point 0.1 into 48. 4.8 joule. 4.8 joule, option E. Okay, done till that. Okay, next sum. 33. 100 millihenry coil. 100 millihenry coil carries current of 1 ampere. Energy stored in an inductor. What is formula for energy stored in inductor? Half Li square. L is 100 milli into 10 raised to minus 3, 1 square. So zero point 0.5 into 10 raised to minus 1. 0.05 joule. Option C. Four. For a circuit shown in the figure, there is one resistance connected across and capacitor connected across V equals to V0 sine of 2 pi ft. The RMS voltage across the resistor is R times RMS current. This is correct. They want which is false statement. Frequency F increases. So XC will decrease. Voltage across the capacitor decreases. Sorry, decrease in frequency, increases XC. Voltage is I into XC will increase. So this is also correct option. Power dissipated equals to the product of RMS current and RMS voltage is also correct. Increase in capacitance increases the voltage. XC will decrease. Voltage is I, XC will decrease. So this is false answer. This answer D. D is the false answer.
Done, sir.
Okay. In the circuit shown in the figure, power dissipated at very high frequency will be mostly in R2 or in R1 or both 0. This is resistance of 20 ohm, 10 millihenry, 1 microfarad, R2 20 ohm connected across alternating source. See, both the branches are in parallel. So voltage is same in branch 1 and branch 2. Voltage will be same.
Yes, sir.
Frequency is greater, they are telling a higher frequency. At higher frequency, XL is greater, XC is smaller, na? Correct?
Yes, sir.
So impedance will be more for which branch? Z1 no? Is greater than Z2. Power is E square upon Z. So Z1 is greater, therefore P1 will be less than P2. So P2 will be greater than P1. This followed?
Yes, sir.
So power in second branch is more. Power in second branch is more. And mostly in R2 because power across capacitor is always less, mostly in R2. Right. Done.
Yes.
Next, R by L has dimension of. What is unit of R? Ohms. L
Yes.
is ohm second. So 1 upon second is equivalent to frequency. Therefore, option D. 37. Energy required to establish current of 4 ampere. Inductance of 2 millihenry. So 200 into 10 raised to minus 300. Energy required is half Li square, half of 2 into 10 raised to minus 1, I is 4 square. So 10 raised to minus 1 into 16, 1.6 joule. Option D. Completed?
Yes, sir. Complete.
Done, sir.
38. Current and EMF through an inductor. In an inductor, current lags by 90, EMF leads by 90. So what is phase difference between them? In inductor, what is phase difference between current and voltage? Yes,
90
what is
degree.
current and voltage is 90 degree, correct. 39. 90 degree means pi by 2 radian. In an AC circuit, E is 100 sine of 100 t volts and I is 100 sine of 100 t plus pi by 3 milliampere. Power dissipated. Average power dissipated is ERMS IRMS cos phi. E0 upon root 2 I0 by root 2 cos of pi by 3. E0 is 100, I0 is 100 milli convert into ampere, pi by 3 means 60, that is half. So 100, 100, 10 raised to 4 minus 3, 10 upon 2 equals to root 2 to 4, 2.5, 2.5 watt. Done 39?
Done, sir.
Okay. 40 years. An alternating voltage is given by A equals to root 2 sine of 100t. It is connected to 1 microfarad capacitor, 1 microfarad capacitor through AC ammeter, reading of ammeter. What reading ammeter reads? Ammeter reads what? IRMS?
Yes.
So IRMS will be I is V by R upon XC. So it will be E0 upon root 2. XC is 1 upon omega C. So E naught omega C upon root 2. Root 2 upon root 2 omega is T ka coefficient 100. C is 1 microfarad. So 10 raised to minus 6. 10 raised to minus 4 ampere, which is same as 0.1 milliampere. Option A. 0.1 milliampere. Can I go ahead?
Yes, sir.
Okay. (42) Choke is used to limit frequency of AC, has iron core. It has got iron core that is founded on iron. 1 minute. अंदर देवेंद्र सर बोलते हैं, देव सर नहीं, देवेंद्र सर. हाँ 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 बरोबर. ठीक आहे. त्याचे मी वर्कशीट पण पाठवतो आणि रेकॉर्डेड लेक्चर पण पाठवतो. ठीक आहे. हा नाही, कॉमन वर पाठवतो ना, मग सगळ्यांना कळेल. येस येस येस. ओके. 42. In an AC LCR at resonance, what happens at resonance? Z becomes R, na? So phi, phase difference phi. Hello? Hello?
Yes, sir.
Yes, sir.
When the resistance circuit becomes purely resistive, then phase difference becomes 0.
Yes, sir.
Yes, sir.
So answer A. Power factor, very important. Some 220 volt, 50 hertz AC. What is power factor? Are you remembering formula of power factor? Yes, say fast. Formula of power factor. Formula of power factor. Is it cos phi? Power
Yes,
factor
sir.
is cos phi. Cos phi means R by Z.
Yes.
Here R total is 40 plus 40. So this will be, Z will become 80 square plus XC and XL ka difference. 100 minus 40 square. That will become 80 upon 6. 80 square plus 60 square. 100 equal to 0.8. 0.8 C option. Done.
Done, sir.
Forty-four. In an AC circuit with only resistance, then EMF is in phase, correct?
Yes, sir.
EMF is in phase. 45. Power factor means cos phi. What is value of cos phi? Varies from 0 to maximum 1. Na?
Yes, sir.
So answer C. Cos ka value maximum is 0 or minimum is 0, maximum is 1. A coil has inductor 0.5 millihenry, that is 0.5 into 10 raised to minus 3 Henry, connected to AC source of RMS value 0.462 volt. If frequency is 49, then what is reactance of the coil? Formula for reactance is omega into L, which is 2 pi FL. Pi 22 by 7, F is 49. L is 0.5 milli, 0.5 into 10 raised to minus 3, 7 into 7, 2 into 0.51, 154 into 10 raised to minus 3, 0.154 ohms. Solve.
Answer.
Okay. Sum number 47. In question 46, RMS current through the coil. Current through the coil is voltage upon resistance. Reactance we got 0.154, voltage is 462. So it is equals to 3 ampere. Option C. 48. In LCR circuit, capacitance made 1/4 when in resonance. Then what should be the inductance so that circuit remains in resonance? So for resonance, F formula is 1 upon 2 pi root LC. That means LC should be constant. Then only it will be same resonance. So L1 C1 should be L2 C2. L1 C1 L2 C2 is made 1/4 of C1. Therefore L2 is 4 times L1. 4 times L1. Option A. Done.
Done,
Done,
sir.
sir.
49. The reactance of capacitor at 50 Hertz frequency is 10. What will be its reactance at 200 Hertz frequency? Xc is 1 upon 2 pi Fc. Xc1 upon Xc2 is F2 upon F1. So 10 upon Xc2 will be 200 upon 50, 50 into 4. So Xc2 50 upon 4, na? Hello?
Yes, sir.
50 Hertz per 10, 50 into 4. 100 upon 4, 10 upon 4, 2.5 ohm. 2.5 ohm. Do you practice properly at home?
Yes, sir.
नहीं, मुझे जहां तक लग रहा है थोड़ा आप लोग बराबर नहीं कर रहे हैं, ऐसा फील हो रहा है, और जब भी मैं फील करता हूँ राइट रहता है मुझसे. Are you not getting time to execute the planner properly? These all MCQs which I am solving, you should practice also. It should not happen only in class you are paying attention. Without practice, you will not understand or remember the concept.
Yes, sir.
हाँ, ठीक है. Shall I clear now?
Yes, sir.
49th period, 50th. A coil of wire having certain radius has 600 turns and self inductance is 108 millihenry. The self inductance of another similar coil of 500 tons will be. L and number of ton ka relation is proportional to n square. So L1 upon L2 will be N1 upon N2 square. 108 upon L2 is 600 upon 500 square. So 108 upon L2 will be 36 upon 25. 108 upon L2 is 36 upon 25. 36 into 3. 75 millihenry.
Done, sir.
51. In a series circuit as shown in the figure, very important sum. Voltmeter and ammeter will read what? RLC. 50 ohm. Here voltmeter are connected, recording 400 volt. This voltmeter reading we want. 100 volt, 50 hertz. Is it resonance circuit? Voltage across inductor, CMOS, capacitor. Is it resonance?
Yes, sir.
Yes, sir.
रेजोनेंस पे ZR बन जाता है ना, तो करंट I E by R होगा ना, यानी कि 100/50 2 एम्पियर आ जाएगा ना करंट.
Yes, sir.
एंड ER is same as E total, which is 100. हो गया ये आंसर. 102 ampere is the answer. B. Yeah. हाँ मुझे नहीं चाहिए. Done.
Yes, sir. Done.
The network shown in the figure, network नहीं है शायद, फिगर में दिया ही नहीं है. Okay, skip that 52 because network is missing. 53. A resistor and capacitor are connected in series with 5 volt AC. The RMS voltage across capacitor is 3 volt. This is how much? E total square is ER square plus EC square. So 5 square will be ER square plus 3 square. 25 minus 9 is ER square. ER is 16. ER square is 16. So ER equal to 4 volt. 54. In LCR circuit, R is 10 ohm, impedance is 20 ohm, then phase difference between the current and voltage. Phase difference means phi. So we can start with cos phi, R by Z. R is 10/20 half. So phi equal to 60 degree. Option C. Complete till this.
Done, sir.
Okay. 53, 54. Sorry, 55. A variable capacitor and inductor are connected in series across AC source of 100 volt. The current in the circuit is 5 ampere. When the capacitor is decreased to half, means C by 2, then current becomes 10 ampere. Voltage is same, 100 volt. The current becomes 10. And then what is voltage across capacitor in the first case? So E, C in first case we want. What is voltage across inductor capacitor का total? Sum or difference?
What, sir?
Total voltage when inductor and capacitors are connected, what we take? Sum or difference?
Some.
Sum. इससे तो बोल रहा हूँ पढ़ते नहीं आप लोग बुक, कुछ नहीं पढ़ते, खाली बैठ जाते लेक्चर में. ई टोटल का फॉर्मूला अब कितना बार लिखाया है? ई टोटल, इसलिए अभी इसके पहले एक सम किया, वेर 400 तो मैंने बोला रिजल्ट 0 हो जाएगा, तो भी आप बोल रहे सम होगा. ये फॉर्मूला है ना टोटल का इन एसी सर्किट. यस, हेलो.
Yes, sir.
What is formula for voltage, total voltage in AC circuit? Write this 10 times. Write down. So that voltage across capacitor, inductor, you will tell me EL minus EC. Write 10 times. Don't lose the rhythm of the studies.
Done, sir.
10 times written.
Yes, sir.
So from here, voltage across capacitor in first case and voltage across inductor, उसमें first second नहीं because it is constant. चलो EL1 is 100. That means I into XC1 minus into XL equals to 100. So I is 5 into XC1 minus 5 XL equals to 100, equation 1. For second condition, 10 times XC2 minus 10 times XL is constant equal to 100, equation 2. 10 times into XC2 is 100. XC2, C becomes half, then XC will become double or it will remain half?
Yes.
यस क्या कंडीशन बताओ, XC क्या होएगा, डबल होएगा क्या हाफ होएगा क्या सेम रहेगा जब C हाफ हुआ तो? कुछ है रिलेशन XC और C का? XC and C, any relation is there? Yes, XC and C, any relation? Not remembering, write 10 times this also.
Sir, half.
Write 10 times, write down. XC is 1 upon omega C. Write 10 times. Please write everybody 10 times. कुछ पढ़ाई नहीं चालू है आप लोग का, मतलब पढ़ाई फिजिक्स का बराबर नहीं चालू है, पढ़ाई तो चालू होगा. Write 10 times. XC is 1 upon omega C. So what do you see relation? Is it inverse or direct?
Inverse.
Inverse means what? C becomes half, then XC will become half or double? So much time you are taking, it should be instant now.
Double.
Double. तो डबल टाइम XC1 हो जाएगा. तो पहले 10 बार लिखो. Are you confused what to study? Dhruv? Dhruv, Mayank? Ashley? You all are confused what to study?
No, sir.
No ना, तो study properly. चलो करो बराबर. Now write this much, then I'm doing further. Please copy this much.
Done, sir.
Done till this. Now XL निकाल दिया तो मुझे खाली XC मिल जाएगा ना. Two equation we got, XL and XC. Somehow I should remove this XL. So multiplying 1 by 2, we get, multiplying 1 by 2 we get 10 XC1 minus 10 XL is 100. So 20 XC1 minus 10 XL is also 100. Subtract this. No, ये 200 ना. Subtract this. So minus 10 XC1 ये cancel, equal to 100. See, because we are not aware XL बड़ा XC बड़ा है, कौन सा बड़ा है? So we got difference. But while taking final answer, you take only magnitude. That is 10 times XC1 is 100. So XC1 is 10. Now EC1 is I1 into XC1. 5 into 10, 50 volt. Five into 10, 50 volt. 50 volt is given in option B. Shall I clear it?
Yes, sir.
So that's all for today. Sunday test on